The rectangular form. It is the form in which a complex number is determined by its horizontal and vertical components. It is expressed in the form a plus bi, where the real number a lies in the x-axis and the imaginary number b lies in the y-axis of the Cartesian plane. For example, we are given 2 plus 2i. We begin by drawing the Cartesian plane, of which the x-axis represents its real component, while the y-axis represents its imaginary component. We then find its coordinates, 2 and 2, and then we draw the corresponding vector. R is the magnitude of the vector, also called the argument. Theta is the angle between the vector and the right arm of the Cartesian plane. R, theta, and the x and y components can be solved for using the Pythagorean theorem or SOHCAHTOA, depending on given data. For example, its x and y components are given, so we will use the Pythagorean theorem in solving. The polar form of a complex number, a plus bi, is determined by the magnitude r and the angle theta of the vector associated to the complex number. It is expressed in the form r cis theta, where r is equal to the square root of a squared plus b squared. Cosine theta is equal to a over r, and sine theta is equal to b over r. We are given 2 square root of 2 cis 45 degrees. 2 square root of 2 is the magnitude, and 45 degrees is the angle from the positive side of the x-axis. To convert rectangular form to polar form, here are the steps. First, you get r using the Pythagorean theorem, given the real and imaginary components. You then disregard I. Next, you get theta using SOHCAHTOA and r followed by the arcsine or arccosine function. Lastly, substitute the values of r and theta, so the answer is in the form r cis theta. For example, 3 plus 4i. First, draw the figure. We then get r. And then we get theta. Now we substitute r and theta to get the answer in the form of r cis theta. To convert complex numbers in polar form to rectangular form, here are the steps. First, use the expanded form of r cis theta, r quantity cosine theta plus I sine theta. Next, substitute the values of r, cosine theta, and sine theta. And lastly, evaluate the expression and simplify your answer so that it is in the form a plus bi. For example, 4 cis 90 degrees. We expand it to r quantity cosine theta plus I sine theta. Then, we substitute the values of r cosine theta and sine theta. We then evaluate the expressions to simplify the answer. Operations involving complex numbers in rectangular form. First, addition and subtraction of complex numbers in rectangular form. We group the real numbers and imaginary numbers separately to add or subtract the expressions. Multiplication of complex numbers in rectangular form. We distribute the first term to the second term, resulting to AC minus BD plus quantity AD plus CB I. Division of complex numbers in rectangular form. You divide the first term by a second term. Since imaginary numbers are not allowed in the denominator when simplifying, the numerator and denominator shall be multiplied to the complex conjugate of the denominator. Operations involving complex numbers in polar form. First, multiplication of complex numbers in polar form. We multiply R1 to R2 while we add theta 1 to theta 2. We then substitute the new R and theta to R cis theta. Division of complex numbers in polar form. We divide R1 with R2 and then we subtract theta 1 with theta 2. We then substitute the new values to our system. De Moivre's theorem. When r cis theta is raised to the power of n, we raise r to the power of n and we multiply n to theta. Finding the roots of a complex number in polar form. The nth root of r cis theta is equal to the nth root of r cis theta subset k, where theta subset k is equal to theta plus 360k all over n, and where k is equal to 0 and it goes on until n minus 1.